So since, and I'm talking about this number here, if that number there is 1, then you can use synthetic division or long division. So you can use synthetic or long division. Again, long works for everything. Synthetic only works if that number in the front is 1. So for synthetic division, you're going to do x plus 9, and you have to solve it. So solve for x, which is x equals negative 9. Now, this is one of the first places people always mess up. They try to skip this, and they just use a positive 9. So you can either write it out and solve it, which is what I highly recommend in the beginning until you get really comfortable with this, or you'll know that if it's plus 9, then you're going to use a negative 9. So you're going to use a negative 9 up in your box. I tell this story like if you can remember picture day back in middle school where they put you in alphabetical order, and then if somebody didn't show up that day, they usually handed someone a card with that student's name on it. So that way when pictures came in, the right person got it back. Our larger polynomial, or whatever we're dividing into, our first one, has to be in order by exponent. So 3, 2, 1, none. And in this case, everybody's present for picture day, quote unquote, 3, 2, 1, none. So we can just rock and roll. If someone was missing, you are going to have to put in a space holder, which I think all of these, do not have that problem. But just to go ahead and start that conversation, because that's another one of the big misconceptions that people have, and it takes me a couple days to get people to listen to me. So if someone's missing, so like if the x squared was missing and it just went x cubed x 49, then you would have to put a 0 in its holding spot. They'll call it a placeholder. Since nobody's missing, we take the leading coefficient. So we have a 1, leading coefficient 6, leading coefficient negative 21, leading coefficient 49. And we are going to work straight down. And I just realized I'm about to poke holes on this paper. So you're going to pull your leading coefficient. So first step is solve, pull leading coefficients, put placeholders if anybody's missing, then drop the first term. Now, hold on to your britches and hang out with me. This is going to be weird, but great at the same time. I'm going to go down and multiply. Negative 9 times 1, which is going to bounce here. It's like a bouncy ball. That's going to give me negative 9. When I work down here, I add. So bounce is multiply, straight up and down is add. So 6 plus a negative 9, or 6 minus 9, which is the same thing, is going to give me a negative 3. Then you're going to take that 9 again. It's going to bounce and multiply. So 9 times 3 is a positive 27. Then we're going to work straight down. Negative 21, positive 27. If I add them together, it's going to give me 6. So negative 9, bounce, which is a multiply. So 9 times 6 is 54, and it's a negative and positive, so it's going to be negative 54. Then working straight down, you're going to add. So 49 plus a negative 54 is going to be a negative 5. And then you're done. Now, you'll see some places, if you Google this somewhere else, where there's a line right here. Whatever is left out here is your remainder. And that is important because this is actually factoring out. So though it is division, we are factoring out x plus 9. If it was a factor, so like going back to a quadratic with 2 binomials, super simple, where you either FOILed or used a box method, they gave you, then it should give you no remainder because it is portion of something that should have multiplied together to give you this to begin with, if there was nothing left here. So since there is a remainder here, that means x plus 9 is not a factor of this polynomial. Okay, so as soon as you see a remainder, just think not factor. Not a factor. Can't be divided evenly. To write your answer, and this is another portion that takes a minute for it to stick in your brain, so you just got to practice. We started with a cubed function, and we're dividing 1 out, so then our answer is going to have to be a squared function. So you're going to take your numbers, 1, negative 3, 6. We're going to write negative 5 up high, and I'll show you why in a minute. And this is going to be an x squared because we pulled 1 out, so that means I still have x cubed. Then the next one is going to be x, and then the last one is going to be a constant. That negative 5, so you can put plus a negative 5 if you want, or you'll see it written as 6 minus 5 over x plus 9. And if you can remember back to very basic long division before you had variables attached to it, your remainder, you would also, sometimes you would write r negative 5. So the answer can also be written, which all of these are fine by me. I'm just showing them to you. Plus 6, because the answer choices could be different as far as like EOC or Delta or next math teacher, because one is not more relevant or more prevalent than the other. So talk to me, or do you want me to just go for another one? Questions yet?
Nothing in the chat box, and we just got Randall back.
Okay. All right, so I'm gonna go for another one because I think it takes a minute for you to even figure out what you don't understand, if that makes sense. But holler if you have a question. In 3 minus 13 squared. And right now I'm just focusing on synthetic because, like I said, worst case scenario, if that's all you pick up in this unit, you'll miss one question on our quiz probably, and then one on the EOC, but these you'll have in the bag, which is still better than none. So again, you want to check 3, 2, 1, none. We're good there. N minus 4 I need to solve. And let's add 4 to both sides. So n is going to equal to 4. 4 in my box. Pull down my leading coefficients. So 1, negative 13, 35, and 12. And again, 3, 2, 1, none. So we're good. So there didn't need to be a space holder. First number always falls down. It is not always a 1. It just happens to be in these two examples. So we're going to take our 4. Bouncy ball. It's going to multiply. So 4 times 1 is 4. Working straight down, you add. So negative 13 plus 4 is going to give you a negative 11. Bouncy ball 4 is going to come down, times that 11, and bounce back up, which is going to give me a negative 44. Work straight down, add, which is going to give me a negative 9. This is one of those things where I mentioned, since you're in Math 3 now and higher level math, use your calculator. Don't chance it on these guys, because that small error will throw off the entire answer, and you will be doing all the hard part and just messed up on something small. So make sure your calculator is available. I did reach out to find out if we could get a calculator embedded on y'all's computers, because I don't feel like it's fair that you're at home on a computer and don't have a calculator necessarily.
Hey, we got a comment. It says, wouldn't it be a negative 9?
Yep, it is negative 9. Did I say positive 9? I'm sorry. I wrote negative. Yes. Good call. 4 times negative 9, bounce, is going to be negative 36. Then we're going to work straight down again. Add. So 12 plus a negative 36 is going to give me a negative...
Ms. Sigmund?
Yes, sir.
Maybe it's just me. You added the negative 13 and 4, right? You added those, right?
Yep. Yes, sir. Working down is always add. Bounce is multiply.
So wouldn't that be a negative 9 instead of a negative 11?
Yup. Good call. That negative 9, I hear you now. I forewarned you. And I didn't use erasable pens. Fail on my part. Yes, negative 9. So back to that, make sure you use your calculator or you make a mistake like Miss Sigmund. So backing up, 4 times a negative 9 is going to be a negative 36. It's going to give us a negative 1 if we add them together. 4 times negative 1, negative 4. And that's going to give me 8. Always check me. Definitely human. And then, again, that means we have a remainder, so hopefully sooner than later our brains will be trained to be like, okay, not a factor. So not a factor. This answer, the question could say, is n minus 4 a factor Or the question could also say, is n equals 4? Like, is 4 a solution? So not a factor. This is not a solution. It's asking the same question. It's just in a different step throughout your solving process. So 4 is not a solution, and n minus 4 is not a factor because there is a remainder of 8. So we're going to pull down our numbers. And then it wasn't n cubed. We pulled out an n, so it's going to be n squared. N, and then it just goes 2, 1, none. And that's why it's important to have those space holders. And then our positive 8 is a leftover, and we're going to just write n minus 4 underneath it as a fraction. This is the only portion that goes over n minus 4. Don't let it slide underneath the other part of your answer. Or again, you can write n squared minus 9n minus 1 plus 8 remainder 8. Remainder 8. Other than my poor addition. Super ridiculous. But does anyone have a question about where those numbers and things came from? Or are you seeing the pattern yet?
I see it.
Okay, cool. Do you want to do one more, or do you want me to skip on to long division? Abby or Steven, either one. Anybody?
Do we have to do long division, Miss Sigmund?
Yes. Because trust me, after a couple days, it's not going to be the worst thing you've ever done, I promise. And because there is a small chance, oh, no, that's not right. There's a good chance that if you get after it like I'm asking you to, you will get it. And there is a very, very, very good chance there's one on the EOC. And you might as well, like, try. Because messing up now is not a big deal. And it'd be really cool if you got good at it, because then the EOC, that question's in the bag. Like I've talked about, like walking in, because I can promise you there's going to be one that you cannot use synthetic.
Okay.
So is it the end of the world if you don't get it? No. Would it be really, really cool and in your favor if you did? Yes.
Miss Sigmund, when it came to long division, the only thing I didn't get is when it was more than one. It was like trinomial, you got to divide by. It was like 3 digits and all that there. And I was like, I didn't really get that.
Because there's more. Right. Okay. There's a lot more. All right. Abby, Steven, you guys go okay on synthetic? And I'll jump to long? Or do you want one more synthetic?
I'm good on it.
Okay. And definitely watch my algebra on long division. I absolutely quit doing those in front of everybody in class, like blindsided. So there's a real good chance that I mess up somewhere. So watch me. Pay close attention. It'll come quick. So I'm going to do the one we just did because we know the answers. And that'll keep me from messing up too much. So x plus 9. So the long way. First, x cubed plus 6x squared minus 21x plus 49. Okay. So you are going to look at your x and x. So x will go into x cubed twice, right? I mean, there'll be 2 left over when I pull 1 out. So this times this gives me this. Or this divided into that gives that. Whichever way makes sense to you is the way you want to train your brain to think. I like multiply. What did I multiply this by to get x cubed? And then that's what you're going to do. So x squared times x gives me x cubed. X squared times 9 gives me 9x squared. Then you're going to work straight down just like old school long division, and we're going to subtract. So these guys cancel out, which is a good sign because you're trying to get rid of things. And then 6 minus 9 is a negative 3x squared. We're then going to look and see what did I multiply x by to get a negative 3x squared. And that's going to be a negative 3 and an x. Because negative 3 gives me a negative 3x times x gives me that 3x squared. So negative 3x squared. Then multiply that by the 9 as well. So negative 3 times 9 gives me a negative 27x. And I'm sorry, I left this part out. Bring this guy down to make your life easier. The next one down. And then we're going to just subtract straight down. That turns that into a positive, so these guys are going to go away. This is going to become a positive as well, because again, you're distributing that negative all the way through. And then negative 21 plus 27 gives us 6x. Is everybody okay so far?
Yes, ma'am.
Perfect. We're going to bring down our 49. So what did I multiply x by to get 6x? And that's going to be that 6. So 6 times x gives me 6x. 6 times 9 gives me 54. And then again, we're going to subtract. This number's both of them, so this is going to become a negative when we're working straight down. These cross out, which is a good sign. If they don't cancel each other out, something's wrong. Like you didn't pick the right number. They have to cancel out in the front. The idea is that you're working through and crossing things out. So then 6 times 9, 54, I'm right there. 49 minus 54 is going to give me a negative 5. And then we're done. So this is your remainder. Which again, just to be repetitive, means that x plus 9 is not a factor and negative 9 is not a solution to this polynomial. And so your answer, if it was just divide, and what is the answer? Was that, which is the exact same thing as what we got here below. They don't fit on the same screen, I'm sorry. And the reason I did one that you could do synthetically is because the numbers seem to stay a little easier. And Randall, like you said, it was good until all of a sudden it got crazy. And the crazy is why you need long division, because crazy won't work for synthetic. So we're going to jump in a little crazier, not super wild. Let's do 3x plus 4.
Hey, Sigmund, before you get hopping,
Yeah.
Can I hop off for a second?
Yeah.
I'll be back in like 5.
Oh, yeah. Okay. No worries.
Thanks.
Yep. And actually, let's back up before I move on. Show you the box method. So what I've told students to do is just start the box. Don't commit to a full box. The first term, oh man, okay, I need highlighters. 4 should be enough, hopefully. Okay. The first few times you do this, if you have highlighters, trust me, use them. It will make your life so much easier. If not, use colored pencils, use colored pens, something, okay? So we have x and 9. It's x plus 9, right? So it's going to be a 2 by, and we don't know how far we're going to need to go, depending. So the first term was x cubed. First term always goes in the first box. So first term goes in the first box, okay? What did I multiply x by to get x cubed? And that's your x squared. And then just like if you were, this is now like a 1 by 2 box method for math 1. You're going to work down, and that's going to give you that 9x squared there. Okay. Now, the second term is 6x squared. This box, and it works on diagonals, and this box, when added together, have to give me 6x squared. So I have 9x squared, and I need to walk away with 6, so I need to spend or lose 3, right? Now those two add together to give me 6x squared. So these two boxes combine to give me my second term. So second diagonal, if you could think of it that way. So diagonal 1, diagonal 2 for our second term. What did I multiply x by to get negative 3x squared? So negative 3 and then one more x. Negative 3 times x gives us that negative 3x squared. Again, we got to work down, so now we're going to drop it. 9 times a negative 3 is a negative 27x. This is what I'm going to change color. So now we're thinking about our third term, that negative 21x. Third diagonal, so this one and this one have to equal a negative 21. I already have a negative 27, so I need to add to it to bring it back to the right to that negative 21. So I'm going to add 6x. And now I need to know, what did I multiply x by to get 6x? 6, right? And then 6 times 9 is our 54. We're not done yet. Getting there. So our final term is 49. So we have 54 in an open box. That open box has to be a number that will turn that 54 or combine with 54 to give me 49. And that's going to be that -5. And we have no more terms, so we're done. And there's nothing I can multiply x by to get a -5. So that's how you know this is your remainder. Your answer is up here at the top. So x squared minus 3x plus 6 with a remainder of -5. Both of these are long division. One is just standard, which I call old school, and then the other is just another organizational method. Both are long division, though. Do you see where they match and you're seeing the same numbers kind of repeating themselves? But in, like I said, a different order?
Yes.
Sweet. All right. Let's do one that's a little uglier, but not terribly ugly. Let's do 8x plus 4 and divide into 8x cubed minus 12x squared. Okay, so I'm going to do box first this time and then work back up. So we got a 2, so it's a binomial, so we know it's going to be 2 high and undisclosed long. I'm just going to start it. So we're going to have our binomial on the x side, outside, down the side. First term goes inside the box in the first diagonal, or the first box. So that 8x cubed is going to go right there. Now, what did I multiply 8x by to get 8x cubed? So numerically, it's 1 times 8 gives me 8. And then x times x squared gives me that x cubed. Also, if you want to be adventurous for this guy and you know that you realize you start mixing things up, if this is an x cubed and everybody's present, so there's no space holders necessary, it's 3, 2, 1, none. This is x cubed, this is x squared, this is going to be x squared, x, x, and then that column, or diagonal, I'm sorry, will be a constant. In class, I used to force is a strong word, require this much has to be on your paper every time you do this. Every time you try one, if you can write that much down, the next time you do it, you will get a little further. It's the commitment to trying to get every small step, and it's probably not going to come all at one time. So start there and get at least that much every time you try to write one down, and then go back and check it or follow along in the video or whatever. But training yourself to know that since it's a cubed, this is going to be x cubed squareds, x to the 1 power, and then our constants are going to be after that. And it'll also help you to see the diagonals and how they work if you choose to do it this way. So x squared times 4 is going to give you 4x squared, which is perfect. And then we're going for our second diagonal. 4x squared and something x squared have to give me a -12x squared. I have 4 and I need to owe somebody 12. So that means I'm actually going to owe 16 or spend 16, if that makes sense. That's going to give me that -12x squared between those two boxes in that diagonal. What did I multiply 8 by to get a -16? It's -2. And then what did I multiply x by to get x squared? It's going to be x. That x, when it drops down, is where this x comes from. -2 times 4, -8. And the reason I also started asking students to do this is because you will know it if I ask you, like straight out, what is 2x times 4? And you would say 8x. Or like the x squared times x. You would tell me x cubed, but when left to your own devices by yourself, these exponents starts getting all kind of crazy funny when you start writing them down. And I think it's more that you're just think the whole thing is horrible, and that's what happens, than that you don't know. So again, it's just one of those avoiding minor mistakes. So now we're into our third diagonal. And these two boxes have to equal a -80 by addition. So when I put them together, they have to equal a -80. I'm already in the whole 8, so that means I need to spend a -72. Yep, -72. So then I need to know, what did I multiply 8 by to get 72? And in this case, it's a -72. So 8 times what gives me a negative 72, and that's going to be that negative 9. Negative 9 times 8 gives me 72, and there's an x, so that's where the x comes from. Then we're going to work down. Negative 9 times 4 is a negative 36. We're getting to the end. So this box and this box have to give me a negative 38. So I've already spent 36, and I need to spend 2 more or take away 2 more to be in that negative 38 place. And there is nothing that I can multiply 8x by to get a negative 2. So then I know this is my remainder. And again, 8x plus 4 is not a factor of x squared minus 2x minus, of the 8x cubed minus 12x squared minus 80x minus 38. This is not a factor of this. And I think a negative 1/2, if I'm not mistaken. Yep. Negative 1/2 is not a solution either. So again, it's the same question, just worded differently. So not a solution, not a factor, because there's a remainder. Your final answer is x squared minus 2x minus 9 with a remainder of negative 2, or again, x squared minus 2x minus 9 plus a negative 2 over 8x plus 4. And I did get an email because I believe in one of the videos they were putting parentheses around that last fraction. You can, or you don't have to. Same kind of with the plus and negative. This might be a minus depending on who writes it and what YouTube video you watch, or who wrote the quiz, or like I said, teachers in the future and EOCs and all that. But just remember that plus and negative is the same thing as subtraction. Abby, I know you mentioned you weren't really a box fan. Do you want me to work this long division like the standard old school way for you too? Or are you okay?
Yeah.
Okay, go for it. All right. 8x plus 4. I realized I didn't leave enough space. Sorry. All right. So working this way. You are going to look at your first term, 8x cubed. What did I multiply 8x by? Or if I divide this by 8x is the other, probably the more mathy way to say it. So this divided by 8x gives me what? And that's going to be that x squared. X squared times 8x gives me 8x cubed, which was our goal. That's good. X squared times 4 is going to give me a positive 4x squared. Then we're going to subtract. And remember, both of them are subtraction because it was a plus. So now we're going to subtract here because it's a positive 4x squared. These cancel out. Negative 12x squared minus 4x squared gives me that negative 16x squared. Drop down the next term. What did I multiply 8x by to get a negative 16x squared? So 8 times a negative 2 would give me 16. I have one x here, so I need one more x. Negative 2 times 8, negative 16. X times x is x squared. Negative 2 times 4 is a negative 8. And there's no variable here, so x is just going to come down with it. Again, you're going to subtract, which makes that a positive and that a positive. So I end up with these guys crossing out, which means you know you're doing your math right. Negative 80x is going to, plus 8 gives you a negative 72x. Then we're going to bring down the negative 38 from up here. What did you multiply 8 by to get 72? And that's going to be at negative 9. There's already an x there, so we don't have an x up here because that's going to take care of that negative 72x when we multiply them together. Negative 9 times 4 is going to give me a negative 36. And then we're going to subtract, which makes both of those plus. So then these cancel out. Negative 38 plus 36, or minus a negative, is going to give me a positive 2. Oh, negative 2. Negative 38, positive 36, negative 2. And then there's nothing that I can multiply 8x by to get out a negative 2. And that's so we're done. So we know this is our remainder. Again, this is not a factor. Our answer is x squared minus 2x minus 9 with a remainder of negative 2, or again, x squared minus 2x minus 9 minus 2 over 8x plus 4. Like I mentioned, the biggest thing is just doing them. Don't use any of the cheater apps if you have them, because it is going to make nothing easier for you except for you to get a question right on your notes and on Edpuzzles or whatever, Delta at this point, and it's practice. It just takes a little commitment and getting after it, and you'll find out where you are going to mess up, because you personally will have a trend at what you do wrong. If you get to working these and you see it where you're just continuously messing up and you don't see your mistake, this is a perfect time to use the Remind app. You can email, I just won't get it instantly, obviously, but screenshot like this amount of work, whatever you wrote down, and send it to me, and I'll look at it and figure out where you're messing up. If you have a couple of them, then you can also send that to me, because I'll probably find that it's the same mistake. Usually we do the same things over and over and over again. I'm going to turn